Good morning everyone. So in that last class we had studied about what we mean by the solution of a quadratic equation, that is what are the roots of the quadratic equation and what are the different ways that we can find the solution of the quadratic equation. So the different ways are, the first one is the trial and error method, the second one is the factorization method, third one is the complete square method, and the fourth one is Sridhara's quadratic method. So in the last class we had studied about the factorization method. So in today's class we will be starting with the complete square method. So this is totally a new method. So let us begin with the complete square method. So you know what is the standard form of a quadratic equation, that is ax square plus bx plus c, where a is not equals to 0. So in the complete square method, the problem will be given of the form of ax square plus bx plus c, where a is not equals to 0 and c must and should be a compulsorily a non-perfect square number. So in the problem they will be giving you a standard form of the equation where c will be compulsorily a non-perfect square number. So the whole process, the whole complete square method deals with making this c, which is a non-perfect square number, to a perfect square number. So the whole concept of complete square method deals with making the constant c, which is a non-perfect square number, as a perfect square number by using the methods that is we will be discussing right now. So I hope what we mean by complete square method is clear. So the problem will be given in the form of ax square plus bx plus c, where c a is not equal to 0 and c will compulsorily be a non-perfect square number. So converting this non-perfect square number to a perfect square number is what complete square method deals with. So after converting it to the perfect square number, we shall simplify it by the methods we will be discussing now. Now we shall see what are the steps to be followed in the complete square method. So first, in the first step, you have to check whether the coefficient of x square is a perfect square or not. So you have to check whether the coefficient of x square is a perfect square or not. So suppose a quadratic equation ax square plus bx plus c is equals to 0 is given. So the coefficient of x square in this case is a. You have to check whether a is a perfect square or not. So if it is a perfect square, then you have to go to the step 3, and if it is not a perfect square, then you have to go to step 2. So assume that it is not a perfect square. Suppose a is not a perfect square. So now let us go to step 2. So if it is not a perfect square, you have to make it a perfect square by multiplying the coefficient of x square to the whole quadratic equation, so that the coefficient of x square now becomes a perfect square. So suppose the coefficient of x square is not a perfect square. Now we have to multiply the coefficient of x square to the whole quadratic equation, so that the coefficient of x square now becomes a perfect square. So after making it as a perfect square, now let us go to the step 3. That is, now we shall try to bring the given quadratic equation in either of the forms, that is a plus b whole square or a minus b whole square. Now by simplification, that is, how do we bring it in this form? We shall just add and subtract the coefficient of x divided by 2 whole square to the given quadratic equation. So after making it a perfect square in step 2, we shall try to bring the quadratic equation in the form of a plus b whole square or a minus b whole square by just adding and subtracting coefficient of x divided by 2 whole square to the given quadratic equation. So here I have used the term as and. So you have to add as well as subtract the coefficient of x by 2 whole square to the given quadratic equation. And after that, the step 4 is simplify until you get the roots of the given quadratic equation. So you have to simplify it until you get the 2 roots of the given quadratic equation. So this was the what are the steps regarding the complete square method. So the first step is you have to check whether the coefficient of x square is a perfect square or not. And if it is a perfect square, then you have to go to the step 3. And if it is not a perfect square, you have to make it a perfect square by multiplying the coefficient of x square to the whole quadratic equation, so that the coefficient of x square becomes a perfect square. And after that, we have to bring the quadratic equation in either of the forms, that is a plus b whole square or a minus b whole square, by adding and subtracting the coefficient of x divided by 2 whole square to the given quadratic equation. And step 4 is simple, that is, you have to simplify the quadratic equation until you get the two roots of the given quadratic equation. So now we shall solve some problems related to complete square method. So now we will move on to the solving problems on complete square method. So solve x square plus 4x minus 5 equals to 0 by complete square method. So first write down whatever they have given, that is x square plus 4x minus 5, which is given. So now here the coefficient of x square is 1. So it is a perfect square number. So we shall directly move on to the step number 3, that is add and subtract coefficient of x divided by 2 whole square. So many of you forget this. Even I forgot this now. So you have to add and subtract coefficient of x divided by 2 whole square to the given quadratic equation. That is, you have to, the coefficient of x in the given quadratic equation is 4 divided by 2 whole square. So you have to, 4 divided by 2 is nothing but 2 whole square. So you have to add 2 whole square to the given quadratic equation as well as subtract 2 square from the given quadratic equation. So again write down whatever they were given, that is x square plus 4x minus 5 equals to 0. Now x square plus 4x, now you have to add this, plus 2 square minus 2 square minus 5. So this minus 5 I have kept it as it is. So now observe, x square plus 4x plus 4. So I'll take this in bracket. So minus 2 square is nothing but 4 and minus 5 as it is equals to 0. So now I will write this as x square plus into 2. Sorry. So now they are given, that is x square plus 4x minus 5. We will write it as x square plus 4x plus 2 whole square minus 2 whole square minus 5 equals to 0. So we have now acquired, that is x square plus 4x plus 4. I have taken this in a separate bracket, minus 4 minus 5 as it is. So instead of writing x square, now instead of writing 4x, I will write it as x square plus 2 into x into 2. So it is nothing but 4x plus, instead of 4 I will write it as 2 square minus, so minus 4 and minus 5 is minus 9, which is equals to 0. So now it is of the form a square plus 2ab plus b square. So I can write it as x plus 2 whole square minus 9 equals to 0. So observe, compare it with the a plus b whole square formula. A plus b whole square formula is nothing but a square plus 2ab plus b square. So it is of the form of a square plus 2ab plus b square. So in the place of a we have x and in the place of b we have 2. So I can write it as x plus 2 whole square minus 9 equals to 0. Clear? So now observe what I told in the introduction part of complete square method, that is to make the constant c, which is a non-perfect square. 5 is a non-perfect square. Now it has become perfect square. So 9 is a perfect square, right? So the complete square method deals with making the constant, which is a non-perfect square, to a perfect square. So this can be now written as x plus 2 whole square is equals to, I can shift this to the RHS, which now becomes plus 9. So this implies x plus 2 whole square. So instead of square, I will take it as square root of 9. So this implies x plus 2 is equals to, so after, you have to be very careful here. So after taking square root, you have to write plus or minus 3. So square root of 9 is 3, but since we have taken the square root, you have to write it as plus or minus 3. So these are the basics of mathematics. So after taking square root, you have to always mention plus or minus 3. So now just equate it. X plus 2 is equals to plus 3 once, or x plus 2 is equals to minus 3 once. So this implies x is equals to 3 minus 2, or else x is equals to minus 3 minus 2. Just I have transposed the plus 2 to the RHS. So x is equals to plus 1 and or x is equals to minus 5. So now we have obtained the roots of the quadratic equation by complete square method. So this is how you deal with the problem when the quotient of x square is a perfect square. Now let us see a problem that is when the quotient of x square is a non-perfect square. Solve 2x square minus 7x plus 3 equals to 0 by complete square method. So write down whatever they are given. So the given equation is 2x square minus 7x plus 3 equals to 0. Here the quotient of x square is 2, which is not a perfect square. Coefficient of x square is equals to 2, which is not a perfect square. So according to the steps, we have to make it a perfect square by multiplying the whole equation by the quotient of x square. So multiplying 2 to the whole quadratic equation. So that it becomes a perfect square. So if you multiply 2 to the whole quadratic equation, it becomes 4x square minus 14x plus 3 equals to 0. So now we have the quotient of x square in the form of perfect square. So now we shall go to the step 3, that is add and subtract coefficient of x whole divided by 2 whole square to the given quadratic equation. So many of you will get confused in this step. Why? Because you will take the coefficient of x now as 14. So you should not take this as the quotient of x. Why? Because you have multiplied it by 2 to make the quotient of x square as a perfect square. So what was originally the quotient of x? It was 7. So you have to take the quotient of x as 7 by 2 whole square. So you have to add 7 by 2 whole square and subtract 7 by 2 whole square. So you don't have to take you don't have to take 14 here. So don't get confused here. You have to take the quotient of x which is given in the original equation. So you have to add 7 by 2 whole square and subtract 7 by 2 whole square to the quadratic equation. So again write down whatever they have given, plus 3 equals to 0. So now 4x square minus 14x remains as it is. Now we will add 7 by 2 whole square, subtract 7 by 2 whole square plus, so this is 6. So to precise it becomes 6 plus 6 equals to 0. So 4x square minus 14x plus 6 equals to 0. 4x square minus 14x, you have just added 7 by 2 whole square and subtracted 7 by 2 whole square and plus 6 as it is equals to 0. So now the next step is just you have to group them. 4x square as it is minus 14x as it is plus 7 by 2 whole square as it is. So now what is 7 square, which is equals to 49 by 4 plus 6 equals to 0. So now we shall move these two terms to the RHS. Now we shall simplify this a little bit more. So instead of writing 4x square, I will write it as 2x the whole square. Okay, and instead of 14x, I will write it as 2 into 2x into 7 by 2. So if you multiply again, you will be getting 14x plus 7 by 2 whole square as it is. So we will be shifting these two terms to the RHS. So it will become plus 49 by 4 minus 6. So now the next step. So this is of the form of a square minus 2ab plus b square. So this could be written as 2x minus 7 by 2 whole square. So why? Because it is of the form of a minus b whole square, which is equals to a square minus 2ab plus b square. So in the place of x we have, so in the place of a we have 2x and in the place of b we have 7 by 2. So this could be written as 2x minus 7 by 2 whole square, which is equals to, now taking LCM. So this becomes 4 into 1, 1 into 4. So 49 minus 24. So this implies 2x minus 7 by 2 whole square is equals to 49 minus 24 is 25 divided by 4. So now instead of taking square, we will take it as square root. So again observe, we have made the constant term which was a non-perfect square, that is plus 3 into a perfect square. Even 25 is a perfect square, 4 is a perfect square. So 2x minus 7 by 2 is equals to square root of 25 by 4. So this implies 2x minus 7 by 2 is equals to plus or minus 5 divided by 2. Why? Because square root of m by n is equals to square root of m divided by square root of n. So this implies square root of 25 by 4 is equals to square root of 25 divided by square root of 4, which is equals to 5 by 2. So now you have to just equate it and simplify it. So this implies 2x minus 7 by 2 is equals to plus 5 by 2, or 2x minus 7 by 2 is equals to minus 5 by 2. Okay, just simplify now. 2x is equals to 5 by 2, minus 7 by 2 becomes plus 7 by 2, or 2x minus 7 by 2 becomes plus 7 by 2, minus 5 by 2 plus 7 by 2. So this implies 2x is equals to, since both the denominators are same, we will add it directly. 7 plus 5 is 12, 12 divided by 2 is 6. And again here also, since the denominators are same, we will add it. Minus 5 plus 7 is nothing but 2 divided by 2, which is nothing but 1. So this implies x is equals to 6 by 2, or 2x or x is equals to 1 by 2. X is equals to 1 by 2. So this implies 3. So x is equals to 3, or else x is equals to 1 by 2. So these are the solutions of your quadratic equation. So I hope how to find the solution when the quotient of x square, and how when the quotient is a non-perfect square, and how when the quotient of x square is a perfect square is clear. So in today's class we studied what do you mean by complete square method, what are the steps to be followed in the complete square method, and we solved two problems, that is when the quotient of x square was a perfect square and when the quotient of x square was a non-perfect square. So in the next class we will be solving some more problems on complete square method, and after that we will be moving on to the next method, that is the Sridhara's quadratic method. So if you have any doubts, you can contact me. Thank you.